Hello everyone, myself Shrikha from Excell Study Circle. Today we are going to start with chapter 1 of NCERT class 9. The chapter name is Matter in Our Surroundings. So the NCERT textbook contains 4 different chapters in chemistry, out of which the chapter 1, which is Matter in Our Surroundings, is going to be very simple. Like we are only having theoretical topics in matter in our surroundings, and all these are going to be very simple. You can easily relate with. There is no numericals in this chapter. So I'll divide this particular chapter into 4 so that it will be very easy for you to learn. Okay, let's begin with. I hope everyone is ready with your chemistry text. Chapter 1, Matter in Our Surroundings. As we look at our surroundings, we see a large variety of things with different shapes, sizes, and textures. Everything in this universe is made up of material which scientists have named matter. The air we breathe, the food we eat, stones, clouds, stars, plants, and animals, even a small drop of water or a particle of sand, everything is matter. We can also see as we look around that all the things mentioned above occupy space and have mass. In other words, they both have mass and volume. So altogether we can say matter is something which has its own mass, which has its own volume, and which can be perceived by our senses, we can see. So for example, the mobile phone that we use, the laptop, the chair, the table, and the air we breathe. So everything around us is made up of matter. So in general, we can say matter is something which has mass, which has some volume, or it occupies some space of its own. Okay, and all the other emotions like the love, hate, anger, etc. cannot be considered to be matter. Why? Because these don't have any kind of mass or volume of its own. I hope this is clear to everyone. Let's continue. Since early times, human beings have been trying to understand their surroundings. Early Indian philosophers classified matter in the form of 5 basic elements: the Panch Tattva: air, earth, fire, sky, and water. According to them, everything living or non-living was made up of these 5 basic elements. Ancient Greek philosophers arrived at a similar classification of matter. Modern day scientists have evolved 2 types of classification of matter based on their physical properties and chemical nature. In this chapter, we shall learn about matter based on the physical properties. Chemical aspect of matter will be taken up in subsequent chapters. So first we are learning about the physical nature of matter, how matter is actually consisting of, and what are the different states of matter, its characteristic property will be learning. Okay, so let's begin with the physical nature of matter. Matter is made up of particles. Okay, since your textbook is regarding the activity based, each activity will give you some idea regarding the concept that we are going to learn. Okay, so let's continue with. For a long time, 2 schools of thought prevailed regarding the nature of matter. One school believed matter to be continuous like a block of wood, whereas the other thought the matter was made up of particles like sand. Let us perform an activity to decide about the nature of matter. Is it continuous or particular? Particular in the sense which is made up of some sort of particles. So what do you people think? Is it continuous or particular? Okay, let's see whether it is particulate or continuous. Okay, so let's go to activity 1.1. Take 100 ml of beaker, fill half the beaker with water and mark the level of water. Dissolve some salt or sugar with the help of a glass rod. Observe any change in water level. What do you think has happened to the salt? Where does it disappear? Does the level of water changes? So definitely after some time we can see that whether the water, whether the sand or the salt that you take will definitely dissolve in water after some time, right? So where does these salt particles have went, or where is this sugar particles went after some time? Okay, why is it disappearing after some time? We know that it is dissolving in water, and what is happening at the molecular level, at the atomic level, we can just check it out. Okay, in order to answer these questions, we need to use the idea that matter is made up of particles. What was there in the spoon, salt or sugar, has now spread throughout the water. This is illustrated in figure 1.1. So they have given figure 1.1. When we dissolve salt in water, the particles of salt get into the spaces between the particles of water. Okay, so we know that the sugar particles or the salt particles will dissolve in water. So where is it going? There is some space in between the water particle, so that in the space we call it as the interparticular space or the intermolecular space of water, the salt particle or the sugar particle is getting in between. Okay, you can see in the figure, we are adding salt to the water, particles of water which is magnified million of times they have shown in the figure, okay, in the textbook. So when we stir it, definitely the dissolving happens much in a quicker way. We can see that the sugar particles or the salt particles will get into the space in between water. Okay, so every matter is made up of some sort of particles, we can say. Now let's go to 1.1.2. How small are this particle of matter? Okay, so activity 1.2, let's check it out. Take 2 to 3 crystals of potassium permanganate and dissolve them in 100 ml of water. So you have to know about potassium permanganate, the color of it. Any guesses? Potassium permanganate is basically dark purple in color, almost we can say blackish, but we can say it is going to be dark purple in color. Okay. All right, we're taking it in 100 ml of water. Take out approximately 10 ml of this solution, put it into 90 ml of the clear water. Okay, so initially we are taking 100 ml of water. We have added 2 to 3 crystals of potassium permanganate into it. And out of the 10 ml only, we are just transferring it to 90 ml of clear water. Okay, now again the third step says that take out 10 ml of the solution and put into another 90 ml of the clear water and so on. Okay, keep diluting the solution like this up to 5 to 8 times. We are taking 10 ml of the each beaker, we are transferring it to the clear water in the next beaker, and the step is continued to 5 to 8 times. Okay, so what is still colored? What do you people think? It's not that much colored. Initially, the potassium permanganate crystals, when dissolved in 100 ml of water, will give you a pinkish kind of color. Why? Because potassium permanganate is already dark purple. So we'll get a purple color of solution or dark pink kind of solution. But when we transfer just 10 ml of the solution into another beaker, we cannot say like it will be completely colorless towards the end. We will be having a light pinkish color to the water at the final beaker as well. Okay, you can see clearly the picture is shown in the textbook, estimating how small are the particles of matter. With every dilution, though the color becomes light, it is still visible. It fades, but okay. Now, this experiment shows that a few crystals of potassium permanganate can color a large volume of water, about 1,000 liters, they would say. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. Okay, so it is made up of millions of particles, and those millions of particles, the tiny fundamental building block of all matter, is said to be atoms. Everything around us is made up of atoms. Matter is something which is made up of that tiny fundamental particles, which is called as atoms. All right. So let's continue. The same activity can be done using 2 ml of Dettol. Instead of potassium permanganate, the smell can be detected even on repeated dilution. Here we can see a color change they have shown in the textbook, but they've asked us to check it with Dettol. Instead of the color change, we can have the smell change. It is very obvious. Okay, the particles of matter are very small. They are small beyond our imagination. Okay, let's go towards the characteristics of particles of matter. We are having 3 main characteristics of particles of matter. First one says that the particles of matter have space in between them. In activities 1.1 and 1.2, we saw that the particles of sugar, salt, Dettol or potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee or lemonade, the normal lemon juice, nimbu pani, particles of one type of matter get into the spaces in between the particles of the other. This shows that there is enough space between the particles of matter. Okay, so the first characteristic of particle of matter is that they are having some space in between them. That is why the first activity that we have already understood, that the salt or the sugar crystals, they are dissolving in water. Where they are going, actually they are getting into the space in between the water particles. So there are some space in between the particles. Okay, now let's go towards the particles of matter are continuously moving. So they have given 3 activities to make us clear that the particles of matter, they are able to move continuously. So activity 1.3, put an unlit incense stick in a corner of your class. How close do you have to go near to it so as to get its smell? Definitely, if it is lit, definitely the smell spreads throughout your classroom. Even you can just check the same experiment in your home itself, we can get that smell, right? Now light the incense stick, what happens? Do you get the smell? Sitting at a distance. Okay, the first one they have mentioned unlit. Okay, you have not lighted it up, but still we get some smell if we go very close to it. If it is lit, even if it is kept at some distance apart, we can get that smell. So record your observation. Okay, if it is lit, well and good, it spreads throughout. If it's not lighted up, so we have to go somewhat closer. Now, activity 1.4, take 2 glasses and beakers filled with water. Put a drop of blue or red ink slowly and carefully along the sides of the first beaker and honey in the same way in the second beaker. Okay, leave them undisturbed in your house or in a corner of your class. Record your observations. What do you observe immediately after adding the ink drop? What do you observe immediately after adding a drop of honey? How many hours or days does it take for the color of ink to spread evenly throughout the water? Okay. So in this particular experiment, they have asked us to take 2 different beakers, where in one beaker we are going to add ink which is blue or black according to your choice, and the second one we need to add few drops of honey. So in the first one, within 2 to 3 minutes, we can say that the ink is spreading completely throughout the water, and if we have taken red, the water will completely change into red in color. If it's going to be like black, it will be black in color. But in the second case, if you are adding few drops of honey to water, first it will just settle at the bottom of the beaker in which the water is taken, and it will take few hours, say about 2 to 3 hours, to evenly spread, right? So more the time will be taken for honey to get evenly distributed in water. But still, from these 2 experiments, it is clear that the particles are able to move, right? The ink particles, they are able to move, and it spreads evenly throughout the water. Even in case of the honey, the first activity also, they say that the incense stick smell, it spreads throughout, right? Whether it is lit or unlit, it is able to move. That is why we are able to get that smell. Again, activity 1.5 definitely proves that the particles of matter are continuously moving. Let's check it out. Drop a crystal of copper sulfate or potassium permanganate. About potassium permanganate, we've already discussed. It's going to be dark purple in color, or almost to the black color crystal. And copper sulfate is basically the crystals of copper sulfate, which is blue in color, into glass of hot water and another containing cold water. Okay, so here we are taking hot water and cold water. We are going to compare. Okay, what's the difference? Do not stir the solution. Allow the crystal to settle at the bottom. We are adding it and we are allowing it to settle. What do you observe just above the solid crystal in the glass? What happens to the time passes by? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with the temperature? Why and how? So what do you people think? Is it going to change with the temperature? If you've taken hot water and cold water, what is the difference? For sure, there is a difference. In hot water, there is a greater chance that the particles mix very easily. Greater the temperature, the particles will be having that enough kinetic energy, the energy which is possessed by the moving particles, we would say. Most probably, you'll be learning about the kinetic energy in your physics chapter, but still, okay. So more the temperature, the particles will be having more tendency to move, and the particles will mix very easily. Okay, so we understood that the particles of matter are continuously moving, right? That is, they possess what we call the kinetic energy. As the temperature rises, particles move very faster. So we can say that with increase in temperature, the kinetic energy of the particles also increases. So whenever the temperature is increased, the particles will be having more kinetic energy. They'll be able to move very fastly. So intermixing can happen at a very faster rate, we would say. So in the above 3 activities, we observe that the particles of matter intermix on their own with each other. They do so by getting into the spaces between the particles. This is intermixing of particles of 2 different types of matter on their own, which is called as diffusion. This is going to be a very important topic about diffusion. So what is diffusion? We can say that the intermixing of 2 different states of matter, of the particles on their own. Okay. Now, the third characteristic properties of matter is the particles of matter attract each other. They have given another 3 activities, where activity 1.6 is going to be very funny. Play this game in the field, make 4 groups and form human chains as suggested. The first group should hold each other from back to back as they've shown in the figure. I hope it's clear to you. And lock arms like Idum Shimmy dancers. Okay, how they have shown in figure 1.3, they are the dancers. The second group should hold hands to form a human chain. Okay, and the third group should form a chain by touching each other with only their fingertips. Now the fourth group of the students should run around and try to break the 3 human chains one by one into as many small groups as possible. Okay, which group was easiest to break? It's very simple. The first group, the Mishmi dancers, likewise, if you're holding from back to back, it will be having some sort of strong force of attraction, we would say. Again, in the case of the group where they are holding their hands, again, some sort of force of attraction is there. But the third one, where they're just touching with the fingertips, it will be very easy for us to just break them out, right? So yes, I hope it's now clear. If you consider each student as a particle of matter, then in which group the particles held each other with the maximum force? Maximum force will be the group 1, where they are holding each other from back to back and they have been locked, right? Next, let's go to activity 1.7. Take an iron nail or piece of chalk and a rubber band. Try breaking them by hammering, cutting or stretching. In which of these above 3 substances do you think that the particles are held together with a greater force? Yeah, when we compare iron nail and chalk and rubber band, definitely iron nail is held with a stronger force of attraction. It's going to be very hard, very rigid, right? Even though chalk and rubber band is considered to be solids, iron is somewhat stronger. Okay, so hammering it or cutting it would be a greater task for us. Let's move towards activity 1.8. Take some water in a container. Try cutting the surface of water with your fingers. Were you able to cut the surface of water? What could be the reason behind the surface of water remaining together? So we'll not be able to cut the water, right? We'll not be able to cut the surface of the water. Why? Because in case of water, the particles are attracted towards each other and we cannot just cut them out, right? So the above 3 activities 1.6, 1.7 and 1.8 suggest the particles of matter have force acting between them. This force keeps the particles together. The strength of this force of attraction varies from one kind of matter to another. There is some sort of attraction between the particles that holds all the particles together. Sometimes it will give some shape to them, size to them, right? So I hope until this it is very clear to you. Now let's go towards the in-text questions. Which of the following are matter? That is the first question. Chair, definitely it is considered to be matter. It has its own mass, volume, it occupies space and all. Air is definitely a matter. Again, it occupies some volume, space and all. Love, it's not considered to be a matter. It doesn't have any kind of volume or mass, right? Again, smell cannot be considered as a matter. Hate cannot be considered as a matter. Almonds, right? All right. So, chair, yes, I can consider. Yes, air also. Then smell, we cannot consider it to be matter. Hate, we cannot. Almonds, yeah, truly, we can consider to be matter. Thought, no. Cold, no. Lemon water, yes, it can be. Smell of perfume, no. So all the emotions or something which cannot be, we cannot find the volume or mass or it doesn't occupy any space, it cannot be considered as a matter. Okay, so the first question is done. Now moving towards the second one, give reason for the following observation. The smell of the hot, sizzling food reaches you several meters away, but to get the smell of, from the cold food, you need to go very close. Yes, for sure. So in case of hot food, the temperature is more. So when temperature is increased, the kinetic energy of the particle is more. When more the kinetic energy, the particles will be able to move randomly in a very faster rate. So diffusion can happen in a faster rate. So intermixing of particles happen in a very faster rate. So we can say that in case of hot wood, diffusion is more. So we have to include the terms like higher the temperature, more kinetic energy, randomly the particles will be moving in a faster rate, I would say, more diffusion, and the smell travels in a very faster rate. Just the opposite, that will be in the case of the cold food, where the temperature is very low, particles will be having less kinetic energy, so diffusion cannot happen at a fast rate. Very less intermixing of particles. I hope that is very clear. Now moving towards the third question. A diver is able to cut through water in a swimming pool. Which property of matter does this observation shows? So diver is able to cut through the water. Water in the form of a liquid where there is moderate interparticular force of attraction. between the particles, okay? And there is some space in between the particles in liquid, that is in water. That is why the diver is able to cut through it. So you have to include two terms over here, the force of attraction as well as the interparticular space in between the water molecules, okay? So you have to elaborate your answer in such a way that you include all the keywords which is very much required for the answer. Now the fourth question, what are the characteristics of particles of matter? We've already understood and learned about the three properties. The first one, particles of matter, they are continuously moving. Then particles of matter attract each other, and every matter, it is made up of very small particle which is called as atoms, okay? So that's all for today's session. So I would like to divide the whole of the chapter into 4 parts. This is your first session. The next session will be uploaded soon, okay? So on a whole, we have learned about matter, examples of matter. Then we have learned that matter is made up of very tiny particles which is called as atoms, okay? And the characteristics of particles, once again I would repeat, particles of matter have space in between them. Then particles of matter are continuously moving. And the third one, particles of matter attract each other. Then we have learned one important concept all regarding the diffusion. It is nothing but the process in which two different states of matters, particles intermix on their own, okay? It increases with the increase in temperature as well. So I hope the complete content of the first few pages of your chapter is clear to you. If there is any kind of doubt or any sort of questions, you can please comment below. We'll be discussing the doubts in the next session as well. So thank you so much for watching.